Good evening, friends. Today we are going to discuss about the previous CTET question paper, wherein we are going to discuss about science pedagogy of and its related questions which were conducted in CTET February 2026. So before going into the discussion of question and its answer with its explanation, let us firstly focus on the syllabus of CTET. If you see, as if the syllabus has no change in it, Maths and Science have equal weightage of 30 questions and 30 questions, each together forming up 60 questions in total. 30 questions for mathematics and 30 questions for science portion, wherein 20 questions are asked from content of NCERT chapters of class 6th, 7th and 8th, and balance 10 questions for 10 marks are asked from science pedagogy part. Let's move on with the syllabus. So the first chapter we would be discussing would be food, under which sources of food, components of food and cleaning food are being covered. The second unit is materials, wherein we would be discussing about materials of daily use. The third unit is the world of the living. Fourth unit is moving things, people and ideas. Next, fifth unit would be how things work, wherein we would be discussing about electric current and circuits, magnets, natural phenomena, and last topic or chapter would be natural resources. So these were the topics wherein 20 questions are being asked for, and the rest 10 questions are pedagogic based, wherein pedagogical issues are being considered. First chapter would be nature and structure of sciences. The second would be aims and objectives of natural science and what natural science is. The third chapter would be understanding and appreciating science. Fourth chapter is approaches or integrated approach. You can consider this topic as approaches which are used in scientific teaching. Next is observation or experiment or discovery method. This chapter would be covering different methods of science. Next chapter would be innovation. The next topic is text materials or aids, which usually include all the variety of teaching learning materials. The next would be evaluation, which covers the three major domains of Bloom's taxonomy: cognitive domain, psychomotor and affective domain, and the problems associated with regard to providing child-centered education, or the problems faced by children in some or the other way. The last chapter would be remedial teaching. So this is the chapters. These are the chapters which are covered in these 30 marks, and under the 10 questions are asked from these topics, which would be covering 10 marks for pedagogy part and 20 marks for content part. Okay, all right. As I have already mentioned that there are 20 questions content based and 10 questions which are asked pedagogy based under the section of science. Today we would be discussing the 10 questions which were asked in the science section of February CTET question paper. So I have provided here with questions, the options of those questions and the correct answer, and according to that option, what is the correct explanation which supports that option. So moving on, first question is, which of the following will not contribute to professional development of science teacher? Let's see the options. Cultivation of hobbies in areas related to science such as robotics and electronics. If you see, a science teacher should have hobbies related to scientific areas like robotics and electronics. So this should be there. So this is not the not option. This is not the wrong option. This is the right option. So here, to answer this question, we have to find out the wrong option. Second option is regular meetings with teachers from neighboring schools. Definitely, there should be a link of teachers among teachers from different schools, so that teacher can gain content wise knowledge as well as practical knowledge of different approaches or methodologies which are used in different schools by different types of science teachers. By types of science teachers, I mean across different levels. Some science teacher at primary level will be using some different methods. Middle school level will be using different method, and similarly higher secondary level teachers would be using different methods. So there should be a proper communication or meeting so that it could help in professional development of science teachers. So option 2 is also correct. Regular reading of science content given in science textbook. No, this is incorrect, because if you see, just reading scientific concepts, it does not help in one or the other way. We should practically apply it. We should enable students to know how we can use each and every concept which we learn in daily life. Option 4 is visit to planetariums, industries and science museums. Definitely we should do. So option 3, regular reading of science content given in science textbooks, is the wrong option. So it would be the correct answer. The explanation given for this question, for this answer, is professional development involves expanding a teacher's horizons. That is, a teacher is able to not limit herself in one place to, for example, only in school. It is not a necessary thing that a teacher must only depend on the school level, school platform to enhance her professional knowledge, right? It should be beyond classroom routine. So textbooks are just foundational resources which are meant for students. Simply reading them does not offer any new pedagogical insight or advanced level growth for teachers. Conversely, cultivating tech-related hobbies, collaborating with peers, and visiting experiential learning sites, as I said, visit to planetariums, industries, and science museums, all activities enhance a teacher's skills and knowledge base. So that's it for the first question. Moving on to the second question. A teacher is doing an activity on density. Students observe that a steel spoon sinks in water but a steel bowl flows. She asks students, why do you think the bowl did not sink? What will make it sink? Which of the following process skills is the teacher trying to develop among her learners? If you see the options, hypothesizing, observing, experimenting, inferring. Inferring means here it refers to the conclusion part. So that is not the answer. Alright? The teacher is doing the activity. So even experimenting is not the correct option. We have to choose one among the option 1 and 2. First option is hypothesizing and second option is observing. The teacher is doing an activity, students only observe it. Here the question is saying that which of the following process skills is a teacher trying to develop among learners. Already the students are observing. So here if you see, she asks questions. Why do you think the bowl did not sink? What will make it sink? So the question, why do you think what will make it sink? This is a question, or you can say this is like a clue or a prompt which the teacher gives to the students to give proper. This is an assumption statement, so you can say it as a tentative statement. So tentative statement is actually the definition of hypothesizing. While students used observation initially, the teacher specifically questions, and these questions are driving them to think forward. So not only merely observing, she is managing herself and making use of the time properly, such that the students are able to think scientifically and understand the topic. So for that, she is able to ask question and help students to find this hypothesis statement. So the answer is hypothesizing. Alright. So moving on. The third question is, read the excerpt given below and answer the question. French scientist Henri Becquerel was working on phosphorescent materials which glow in the dark after exposure to light. He believed that sunlight was the reason that the crystal would burn its image on a photographic plate. On a stormy day in 1896, he decided to leave it for a few days and resume his experiments later. A few days later, he took his crystals out of a darkened drawer. He noticed that the image burned on the plate was fogged, which meant that the crystal had still emitted rays despite the lack of sunlight. So if you see it refers to a scientific experiment done by scientist Henri Becquerel. Here he doesn't do or perform his experiments continuously. He resumes it after a few days, but when he tries to resume it after a few days, something differently happens, based on which the question is being asked. What does the above excerpt illustrate about science? Scientific discovery can be serendipitous. Science is a solitary pursuit. Scientific knowledge is tentative. Scientific is procedural more than creative. Absolutely, all the four options actually tell correctly about science. But here in this case, the scientific discovery, it can be accidental as well. Serendipitous. The word serendipitous means some discoveries which are done due to accidents or unexpected luck. These type of experiments are known as serendipitous. I'm sorry, I don't know what happened to my voice. Serendipity means making valuable discoveries by accident or unexpected luck. Becquerel did not plan to test the crystal without sunlight. A stormy day forced him to alter his timeline, leading to the accidental discovery that the crystal emitted rays on its own. This beautifully highlights that while science is systematic, many breakthroughs happen due to chance observations. So this discovery was actually an accidental discovery. So serendipitous means something which is discovered based on luck or accidentally. Question number 4 says that which of the following attributes which would you associate with scientific temper? Okay, perseverance in carrying out scientific investigations. Yes, perseverance is must. Second option, creativity in coming up with big problems to be investigated and breaking them down into smaller solvable parts. Yes, one should be able to break down a complex problem into simpler parts and find the solution for it using his or her creative thinking or creativity. Skepticism towards non-scientific beliefs. Yes. Commitment towards cultural preservation. Commitment towards cultural values doesn't cover under the topic of scientific temper. It completely focuses on scientific nature of our science subject. So option D would not be there. So option 1 says ABD no, ABC is the correct answer, ACD no, ABCD is no. So the correct answer is option 2, A, B and C. Which of the following tasks would be least suitable for developing an understanding of the relationship of science with society among learners? They are asking which of the tasks would be least suitable. First one is debate on nuclear energy. Second one is group project on latest developments in science and technology. The third one would be concept map on sources of energy. The fourth option is poster competition on contribution of Indian scientists to the world. If you see, the question asks which is the least suitable task. If you see, all the questions should be answered when regarded with any pedagogy. Let it be maths pedagogy or science pedagogy, social science pedagogy, English pedagogy, or any pedagogy questions. The question should be answered in such a way that the answer is child-centered. That is, it supports child-centered education. If you see debate on nuclear energy, that's actually fine because it leads to active learning of students. They would be interestingly participating. The second one is group project. Project method is actually a student-centric method. So if you see, option 2 is also correct. Option 3 says concept map on sources of energy. If you see here, here there would be least participants. Student would not be learning actively. They would be passive learners in case of concept mapping. Teacher would directly either draw the concept map on the board, and the students would be just directly copying it in their in their notebooks or diaries, anything, whatever you are connected with. So option 3 would be the least suitable, even though let's check with option 4. Poster competition on contribution of Indian scientists to the world. Actually, poster competition leads to building of creativity among students. So actually option 4 is also a suitable one. So only option 3 is the least suitable. So option 3 is the correct answer. Here the explanation given is a concept map on energy sources is a purely cognitive conceptual tool which is used to understand scientific facts, categories and relationships. It does not inherently explore human impact policy and societal debates. On the other hand, debates on nuclear energy, tech development tracking and recognizing local scientists, global impacts, directly bridging the gap between scientific advancement and its societal implications. So option 3 is the correct answer. Question number 6. While discussing about nature of science in his class, a teacher makes the following remark. A scientist is open-minded. What does this remark highlight about scientists? They constantly come up with new ideas. They also consider ideas which go against their own ideas. They openly share their ideas with everyone. They do not agree with the views of other scientists. They constantly come up with new ideas. No. It takes time. It depends on person to person. So option 1 is wrong. They also consider ideas which go against their own ideas. This could be the answer. Option 3 says they openly share their ideas with everyone. No single scientist till now have shared his or her views until his discovery is been completed successfully. He or she would be announcing it publicly only. Otherwise, the other people would start researching on his topic. So, no scientist would openly share his ideas completely with everyone. only to those people who he feels free, that they would not reveal his experiments, he would comfortably share with. They do not agree with their views of other scientists. Yes, they do not agree actually. All the scientists try to oppose other scientists by giving priorities to their own statements. So a correct answer is option 2. They also consider ideas which go against their own ideas. The explanation for this question is, if you see, in the philosophy of science, open-mindedness means intellectual humility, that is, the willingness to look at new data, re-examine established theories, and objectively evaluate conflicting evidence, even if it challenges one's own deeply held hypothesis. It does not mean blindly sharing everything or automatically disagreeing with others. Question number 7. In a science class, Mr. Sumit brought some material. It was a water bottle, a glass, and thick paper sheet. He poured water in the glass and put the thick paper sheet on it. Slowly and carefully, he inverted the glass and removed his hand from there. Learners were surprised that paper had stuck on the glass and water was not coming out. Some students said that paper had glue inside, while others said it had stuck due to the water inside the bottle. What, according to you, was the objective of doing this task? The options are: help learners to understand experiments are the principal route to scientific knowledge, encourage learners to construct explanations based on their observation, and option C says encourage learners to ask questions. So in a science class, Mr. Sumit actually brought some material. It was water bottle, glass, and a thick paper sheet. So it is actually a prompt. This prompt actually describes a classic discrepant event. Actually, it's an unexpected outcome that contradicts intuitive logic. It actually it naturally provokes the driving nature of students, provokes their curiosity, right? When they are provoked, and because of their curiousness and curiosity, they are able to ask questions, and they are able to construct initial explanation based on what they have observed. But you see, statement A would be incorrect because an isolated demonstration does not prove that experiments are the only or a principal route to knowledge, nor it is the primary immediate objective of this specific thought-provoking engagement. To be simple, experiments are not only the way to be simple, to say in simple words, experiments are not only the way to construct scientific knowledge. So option B and C are correct. So option 2 says that B and C are the options. So option 2 is the correct answer. Moving on with the 8th question. Read the following excerpt. There was a belief that all living beings on earth were created by God. However, Darwin and Wallace came up with the idea that life forms evolved on the earth from previously existing forms of life. What does the above excerpt illustrate about the nature of science? Science is value neutral? No. Science progresses by following the scientific method? Yes, it is, but here it is not being discussed. Science is tentative. Here there is a word belief. Belief means we are assuming something. So we are creating hypothesis, which is actually a tentative statement. So option 3 is the correct answer. Option 4 says science is interdisciplinary. It is interdisciplinary, but here this point is not being discussed. Question number 9 says, a student has an alternative conception that air contracts on heating. Which of the following strategies would you adopt to challenge this alternative conception? Explain the difference between conduction and convection to illustrate that air is a poor conductor of heat. See, explanation is a method where teacher is more given priority. So that is wrong option. Ask students to do an activity which involves filling a plastic bottle to half of its capacity with very hot water, capping tightly and keeping it aside for few minutes. Ask students to note down the observations. And option 3 says, ask students to refer to the textbook for examples. Why should we make students be passive explorers of knowledge? They should be actively participating. Option 3 is also incorrect. Ask students to attach a deflated balloon to the mouth of a bottle containing air and place the bottle in water bath containing boiled water and note down the observations. If you see option 2 and option 4, option 2 is something we are performing. They are asking to perform with hot water, which may turn risky. So option 4 is the correct answer. The pedagogical explanation also shares the same thing, where pedagogy demands a cognitive conflict strategy where students physically witness data that contradicts their belief. Placing the bottle in boiling water heats the air inside, causing it to expand and inflate the balloon. This direct visual evidence proves air expands when heated. Option 2 causes the air inside to cool down after sealing, which would actually make the bottle collapse, proving air contracts on cooling, confusing the student's specific promise. So actually the option 2 is supposed to prove the opposite of the actual statement. That's why we are avoiding the option 2 statement. Last question of Science Pedagogy CTET February 2026. Read the following and choose the correct option. Assertion statement is, it's an assertion reason question. Assertion statement is, science textbook should include biographies of scientists. Reasoning, narrating biographies of great scientists inspire students to learn how scientists make discoveries by following a universal scientific method. See, assertion is correct because science books should include biography of scientists so that students may be able to know in an easier manner about the discoveries of different scientists and what all the major findings of different scientists. Reasoning statement says that narrating biographies of great scientists inspires students. Definitely it inspires students to learn how scientists make discoveries, but they do not follow a particular universal scientific method. Here universal scientific method refers to a single method which all the scientists would prefer to use to find any new discovery. This is not possible, right? So here the assertion statement is correct and reasoning statement is wrong. The options given are both A and R are true, A and R are not true, R is not true. Both A and R are true, but R is not the correct reasoning. No. A is true, but R is false. Option 3 is the correct option. And option 4 says both A and R are true. Option 4 says that both A and R are false. No, A is true, but R is false. So option 3 is the correct answer. The explanation of this is Assertion is true because, as I said, biographies humanize science, shows historical context, and inspire students. It could motivate students to learn in a more better practical way. However, reasoning statement is false because modern science education rejects the idea of single. Here, assertion is true because biographies humanize science, show historical context, and inspire students. However, reasoning is false because modern science education rejects the idea of a single, rigid, universal scientific method because all scientists systematically follow different methods, not one single method. Discoveries are happening through diverse paths actually right now, through serendipity, observational studies, accidental findings, and non-linear modeling. So there are different paths through which discoveries are being made, not only single method is being followed. So option 3 is the correct answer. I hope you all understood all the 10 questions which we have discussed today in Science Pedagogy questions of CTET paper 2 conducted on February 2026 this year. Thank you all. Do like, share and subscribe to our channel Learn with Indra Lakshmi and turn on the notifications icon to stay updated with the updated videos which I am going to just publish in my channel. Thank you all.